we have done some basic formulas, which is very much required for the further studies of trigonometry. That is, which will be helpful for you in your 10th standard as well as for further classes. So we have completed practice set 8.1 question number 1. Remaining 3 questions we will complete today. Let me first begin with the formulas that we have done in our last class. So first was sine ratio, or you can say sine theta. But when it comes to theta, we should have a diagram. Okay. So sine, cos, and tan. Sine means sine function, cos means cosine function, tan means tangent. So all these are actually based on right angle triangle. So we should have a right angle triangle. This is 90 degree. Say give it a name A, B, C. Suppose this be our theta. Angle C be our theta. We have assigned angle C to be theta. I have told you that theta is nothing but a Greek letter. Theta, alpha, beta. This we use in mathematics to assign a name which will be using or which will be useful again and again. So I have here assigned angle C to be theta. Now, opposite of angle theta is AB, as we have done in our last class. Adjacent to angle theta is BC. And in right angle triangle, hypotenuse is fixed. So AC is fixed as hypotenuse. Side opposite to 90 degrees hypotenuse. It never changes. If you are going to consider theta here, then opposite side becomes BC. This is only the difference. And we know that in triangle ABC or in any triangle, sum of a measure of all angles of a triangle is 180 degree. Okay. So this is 90. So remaining 2 will be 90. No doubt. Addition of 2. We will see this further. Let's first complete question number 2. So before completing, we are doing the formulas that we have done in our last class. So sine theta. Formula for sine theta is nothing but opposite of opposite side of angle theta divided by hypotenuse. This is the formula for sine. Cos theta. Yes, cos theta. Adjacent side of angle theta divided by hypotenuse. You should remember this formula. Very useful in solving. If you know everything, you know opposite side, you know adjacent side, but you don't know the formulas, then you won't be able to execute the problems. Tan theta. Tan theta formula is opposite side of angle theta divided by adjacent side of angle theta. So these are the basic formula which will be useful to complete our practice set 8.1 today. So everyone please remember this. So let's start with question number 2 now. What they have given? Everyone just go through the question once so that you can understand and you can solve it by yourself if required. In right angle triangle, XYZ, angle XYZ is 90 degree. Okay. XYZ is 90 degree means angle Y is 90 degree. The letter which is kept in between, we treat that to be angle. And A, B, C are the lengths of the side as shown in the figure. Okay, I will draw the diagram first so that I can explain you. So, given part, triangle X, Y, Z is a right angled triangle. Okay. Angle X, Y, Z is equal to 90 degree. And ABC, they are saying ABC are the lengths of the side as shown in the figure. So we will be saying A, B, and C, small letter. Small a, small b, and small c are the lengths of side. You can give it a name as we can see a diagram. I will draw this. So this is our right angle. So here they have said y should be the right angle. So x, y, z, and a is yz, b is xy, and c is our hypotenuse. So you can now mention here A, B, and C are the lengths of the side. A represents the length of YZ, side YZ, comma, B represents length of a side XY, and C represents length of a side in the sense hypotenuse, you can say, but this is side XZ respectively. Respectively represents first length corresponds to first side, second to second, third to third. That's why we have said
Sorry to
respectively.
disturb you. The view is very blurred.
View is very blurred.
Yes, sir.
Ma'am, wait. Ma'am, actually, yeah, 1 minute, ma'am. I will on the line.
Okay, okay.
Z is C and length of side YZ is A. Ma'am, is it clear now? This much we'll do.
Sir, only Z, X, Z, X, and the other letter is visible. The triangle name. That's
Okay,
it.
okay. Means the length is not visible. Whatever I'm writing A, B, C.
A is blurred out. Just C is visible.
Okay, okay. Uh, yeah. So I will increase the size of a font, which will be a small letter, no doubt. This is B, and side YZ is A, side
Okay, sir, that is
XZ.
better. Thank you.
Yeah, ma'am, thank you. This is C. Triangle X, Y, Z is a angled triangle along with this right angle triangle. What else they have given? They have said angle x, y, z is equal to 90 degree and length of, as well as you can write like this, length of xy. Last time we have written a statement. So instead of statement, we can use this notation, as we know that length of any side is given by small l of side. So this will do. So L of xy is small b, comma, length of yz is small a, comma, length of xz is small c. Okay. So these are the nothing but given part. So what they're asking us, they are asking us to find sine of first one, sine of x, second, tan of z, third, cos of x, and fourth, tan of x. We will execute this step by step. So let's start with sine of x. I will rub this. Hope okay. Even I can write here the lower part, which is visible to you. Okay. So first, sine of x. Sine of x, formula for sine of x. We can see that x is on the top and opposite side to x is yz. And hypotenuse is fixed here, xz. So first we will write the formula, then we will write the sides, and then we will write the values, that is the length. Okay. So sine x is equal to opposite side of angle x. The side which is opposite to angle x divided by hypotenuse. As we know that hypotenuse is fixed. So this is equal to opposite side of angle x. X is here. So opposite to angle x, you can see who is opposite to x, yz. So write yz divided by hypotenuse is xz. So this is equal to value of length yz is a. So you should write here a divided by hypotenuse is fixed, that is c. So this is the value for sine x. Now we will move to solve the second trigonometric ratio, that is tan of z. Second, tan of z. Tan of angle z. Now we can see here Z is at the bottom and opposite to Z is XY and adjacent to Z is ZY as well as ZX, but we'll be selecting ZY. In the earlier class, I've explained you that hypotenuse is always fixed, and whenever it comes to an adjacent, we should always ignore hypotenuse part and we should take adjacent as YZ. So write formula for tan Z, opposite side of angle Z divided by adjacent side of angle Z. So from the given figure, we can see opposite side to Z is XY. Side XY is opposite. Here is Z. And side opposite to Z is, angle Z is XY. And the side adjacent to angle Z is YZ. Now tell me, what is the value of XY length? What is the length of side XY, which is B, divided by length of side YZ is A. So this is our answer. It seems to be very simple. There's only a thing you should know: the opposite side of the angle they are asking, adjacent side of the angle they are asking, and hypotenuse is fixed. So don't get confused in adjacent and opposite. Opposite means the side which is in front of that angle. Or facing to that angle, you can say. The third, cos of x. Formula for cos of x is anyone adjacent? Yes, good. Adjacent side of angle x divided by, yes, hypotenuse. So once you remember the formula, you can answer it easily. And now go to x, adjacent side to x. As you can see, xy and xz, but we'll be selecting xy. Reason, as this is the hypotenuse. Who? Xz. So adjacent is xy divided by hypotenuse is xz. Done. This is for side, but we have not given the length. We require length. So write its length. Xy, value of xy is b divided by hypotenuse value is c. So b by c is the answer. This is our final answer. As they have asked in terms of length, you should mention length at last. If you will give answer in terms of side, you won't be getting full marks. So next, that is tan of x. Formula remains same. As we are having tan of z here. Just only a thing, we will replace angles by x, angle x. So tan of x is equal to opposite side of angle x divided by adjacent side of angle x. So now go to x, see angle x. Who is in opposite or who is in front of angle x? YZ. So write YZ divided by adjacent to angle X is XY. YZ. What is the value of YZ? YZ is A. And value of or length of side XY is B. Done. This is your final. So we have completed question number 2 of this exercise. Now we'll move to third question, in which they have given angles, but angles in terms of actual values. That is 40 degree, 50 degree. We should not be afraid of all this. It can be easily solved. Yeah, what they have given in right angle triangle. LMN, angle LMN is equal to 90 degree. Let's draw the diagram first. This is our, say, right angle L, M, and it is having 90 degree at M, angle M. Okay. L is given to be 50 degree and angle N is given to be 40 degree. So they are asking us to find again the trigonometric ratio, that is sine, cos, tan, and cos. So let's do it. At the following ratios. Okay. So given first, very important in geometry, you write given part to proof part and then proof part, because every aspect is having some marks. Say given is having some marks, to prove is having some marks, diagram is having some marks if you draw it properly, and then your formulas and your actual solution. So given part, triangle LMN is a right angle triangle. Right angle triangle with the condition that angle LMN is equal to 90 degree and angle L is equal to what? 50 degree. Angle N is equal to 40 degree. And even you can see that sum of measure of all angles of a triangle. The basic idea behind this is to make you understand that if one is 90, then remaining two angles will also be a 90 degree. As you can see, 50 plus 40, 90. If you will be writing 50 and 60, so it will avoid case, null case, in which the diagram is non-acceptable, because we know that sum of a measure of all angles of a triangle is 180 degree. And any triangle having more than 180 degree will not be satisfying its standard rule of its sum. So 50 degree. Here you can say angle L is complementary to angle N and angle N is complementary to angle L. So now we will execute the problem, that is to find sine 50 degree first, second is cos 50 degree, third tan 40 degree, and fourth cos 40 degree. First one, sine of 50 degree is equal to opposite side of angle L, you can say, or you can write angle is 50 degree, opposite side of 50 degree divided by hypotenuse, because it is the value of angle. So we are writing 50 degree. Hypotenuse is a measure of angle. So we'll be writing only 50 degree, no problem. Now, opposite side of 50 degree is MN, opposite to 50 degree. And the side in front of 50 degree is MN divided by hypotenuse is LN. This is your answer. Answer for sine 50 degree. Similarly, we can go for cos. I will do it here only. Second, cos of 50 degree they are asking. So you should write the formula properly to avoid the mistakes. Adjacent side of adjacent side of 50 degree divided by hypotenuse. So we can see that adjacent side of 50 degree is now adjacent to 50 degree. You can see here L is 50 degree. Adjacent to 50 degree is LM as well as LN, but LN is hypotenuse, so won't be selecting this. So our adjacent is LM. LM divided by hypotenuse is fixed, so LN. This is the second part. Move to next, third one. That is tan of 40 degree. Third, tan of 40 degree. The formula for tan is opposite side of 40 degree divided by adjacent side of 40 degree. Opposite side of 40 degree. You can see opposite to 40 degree is LM. Side opposite, or you can say in front of 40 degree is LM divided by adjacent side of 40 degree. Who is adjacent to 40 degree? Always you have a confusion that LN or MN. LN is hypotenuse. Ignore that. Go for MN. The correct answer. That is fourth part. Cos of 40 degree now. cos of 40 degree is equal to adjacent formula for cos. Adjacent side of 40 degree adjacent side of 40 degree divided by hypotenuse. So 40 degree adjacent to 40 degree is Mn as per our understanding. Divided by hypotenuse. Hypotenuse is Ln. If somebody by default says ki our hypotenuse is adjacent, then what you will get answer ln upon ln. In that case, you will be getting answer 1. So it becomes a doubtful case. So we have completed third question of practice at 8.1. We will move to question number 4 now. Now here they have given one triangle in which they have divided the triangle in two parts. In one right angle triangle, they are having a Greek letter alpha, and in another right angle triangle, they are having a Greek letter theta. So accordingly, we have to give their answers. So let's see how they have drawn a diagram. They are having a triangle of this type. Here. And they have divided into, with this perpendicular, they got two right angles. They're having R, Q, S, and P. Because of this perpendicular drawn, PQ, they got two right angle. One right angle triangle PQR and another right angle triangle PQS. Okay. So as per requirement, they have given angle R to be alpha. And angle, not the whole P, but the angle QPS. They have given it a name as theta. So whenever you go for the right angle triangle PQR, we have to ignore this part. We should not look to this matter. Opposite to angle R is PQ, but not PS. Because we are talking about the right angle. So we have to consider only this right angle, not the whole triangle. If we are dealing with the angle alpha or angle R in triangle PQR, then the opposite to angle alpha is PQ. You have to understand this, huh? Otherwise, you will make a mess. You will say side opposite to alpha is PS. Yeah, if we'll be considering the whole triangle, then opposite to alpha is PS. Okay. But when we are considering only right angle triangle PQR, that is the half, not half, but a part of the whole triangle, then we have to concentrate for that triangle only. So let's move to this problem. Given part, angle as they have given, we should write triangle PQR is a, this is our understanding. If any of the angle of a triangle is 90 degrees, then we can say that that triangle is a right angle triangle. They have not mentioned, but as per understanding, we will write triangle PQR is a right angle triangle with angle PQR is equal to 90 degree. Comma, what else about this triangle? Angle PRQ is equal to alpha. Also, as we are dealing with another angle, I will be using black color. Triangle PQS, so that you can distinguish that we are dealing with two right angle triangles. That's why I'm doing this. Is a right angle triangle with angle PQS is equal to 90 degree. Angle QPS is equal to theta. So this is the given part. And they are asking us to find the following trigonometric ratios. They are divided into two parts. First, for one triangle with Greek letter alpha, that is the triangle PQR, and next for triangle PQS with the Greek letter theta. So let's start with the further proceedings to find first sine of alpha, cos of alpha, tan of alpha. Second, sine of theta, cos of theta, tan of theta. So for alpha, we should consider the triangle PQR. We should mention specifically that we are dealing with this triangle, or else you will do a major mistake, which is unavoidable. So, right, in triangle, as we can see that alpha is in triangle PQR, you know, from here. So we are dealing with this triangle only, PQR. In triangle PQR, angle PRQ is equal to alpha. So sine of alpha is equal to opposite formula, opposite side of angle alpha. Actually, it is a value, so just write alpha divided by hypotenuse. So opposite side of alpha, just hide this triangle PQS. You can see side opposite to angle alpha is PQ, right? PQ divided by, now hypotenuse 90 degrees here. Angle Q is 90 degrees. So side opposite to 90 degrees hypotenuse. So PR. Yeah, this is the answer. As there's not mentioned any value, so we will consider this only. Now we will move to next, that is cos of alpha. Cos of alpha formula is adjacent side of alpha divided by hypotenuse. So again in that same triangle. Sorry. Again in that same triangle, just hide this. We can see alpha is here. So adjacent to alpha is RQ and PQ, but RQ and PR. PR is nothing but opposite to 90 degree. So it is a hypotenuse. So we'll be considering adjacent to be RQ. So adjacent side of alpha is RQ divided by hypotenuse. Hypotenuse is PR. So even this part is done. Next is tan of alpha. Tan of alpha is nothing but tangent of alpha. So tan of alpha, formula for tan is opposite side of alpha divided by adjacent side of alpha. Opposite side of alpha alpha's opposite side. Now, since we are dealing with triangle PQR, just hide PQS. Now you can see opposite side of alpha is PQ and adjacent of alpha is RQ. So answer for this is PQ divided by RQ. Done. Very easy. Easily we have solved this problem, and we can see that once we are very much thorough with the understanding of opposite side and adjacent side opposite to 90 degrees hypotenuse, then we can easily cope up with any type of problem of this trigonometric ratios. Now we have completed the problems based on the first right angle triangle, that is PQR. We'll start with PQS. In triangle PQS. Okay. They are asking why we are dealing with PQS. Now they are asking for theta. So right angle triangle is this part, PQS. I will rub this part now because it is not required any further. Now we can easily do because we have completed this type of problem. In triangle PQS, they are asking us first to find the sine theta. Formula is opposite side of theta divided by hypotenuse as per the formula. If you want to write angle theta, that will do. If you're writing theta, even that will do. As we have written alpha, so here we will write theta, no doubt. We will do. Because theta is the value of angle. Angle P is equal to theta. So is equal to opposite side of theta is QS. Here, opposite to, or the side in front of theta is QS or SQ will do. Divide by hypotenuse. Hypotenuse is fixed, that is PS, opposite to 90 degree. So this is sine theta. Go for cos theta. Cos theta is adjacent side of theta divided by hypotenuse is equal to adjacent to theta. Here we are having theta. Adjacent to theta is PQ. Divided by hypotenuse is QS. No, QS is not hypotenuse. You can see opposite to 90 degrees, PS. Okay, good. So PS. Last now, tan theta. Opposite side of theta divided by adjacent side of theta. Opposite side of theta. Theta's opposite side is QS. Divided by adjacent side of theta is PQ. Okay. So we have completed all the problems of practice set 8.1. Hope you are very much thorough and you have understood it properly. Hopefully things are going good. And now, before winding up, I will like to do one basic which is very much required for our next class, that is complementary angles. Here, as I've already told you, if we are having a right angle triangle, say A, B, C. This is 90 degree, this is theta. We know that angle A plus angle B plus angle C is equal to how much? 180 degree. Sum of measure of all angle of a triangle is 180 degree. Okay, we have having a good understanding of this. So angle A plus value of angle B is 90 degree. So write 90 degree. Angle C is theta. So write theta is equal to 180 degree. Want to find this A. So I'm doing it for that. So angle A is equal to taking this 90 and theta to right hand side. 90 minus theta. So this is 180 minus 90 is 90. So 90 minus theta. Angle A is 90 minus theta. Right here. This is 90 minus theta. Now, we can see angle A is 90 minus theta and angle C is theta. Nothing to do with this B. Here, angle A and angle C are complementary to each other. Complementary. What do you mean by complementary angle? Some should be 90 degree. Yes, one is 90, so remaining two will be 90. So angle A is complementary to angle C. Angle C is complementary to angle A. You should remember this. So we will stop our session here, and in next class we will elaborate this concept. Yeah, thank you everyone.